So I'm going to go through this spiral because I did a nice representation, I think, of a lot of the solving that you may have to do on a Regents exam. So starting with a rational, which is fractional, you want to get a common denominator on all three. It's very tempting to try to make the -5 into a +3, but this works at a unit. You can't touch any piece within the polynomial. So you simply have to add a p plus 3, give this one a p minus 5, and give this one a p minus 5. So all denominators p plus 3, p minus 5, p plus 3, p minus 5, p plus 3, p minus 5. So they can be dropped, keeping in mind that -3 and 5 would have to be rejected if they happen to come up. Oops, I forgot to give this a p minus 5. So then you're just solving the equation from the numerator. So 3p times p plus 3 has to be distributed. -2 has to be distributed. And then p has to be distributed. And we have a quadratic. So we're going to get it all equal to 0 by subtracting this p squared over and adding the 5p over. And we get 2p squared. There's 14 minus 2 is 12 total. All divisible by 2. So if I divide everything by 2, I get p plus 5 and p plus 1. So p equals -5, which is okay, because remember we were going to reject +5. And p equals -1. The next one, solving a radical equation. So rational, get a common denominator. Radical, you have to isolate the radical, so I'm going to add this over. And there's 2 radicals, so this is one of the trickier ones. I just have to isolate one of them to start, and I'm actually going to have to do 2 layers of this, which makes this one of the tougher types. But isolate the radical, square both sides. So when you square this side, the isolation makes the square and the square root just cancel. But when you square this side, because it's something plus something, we have to FOIL. So this side becomes x plus 14, no problem. This is 1 plus the radical times itself, 1 plus the radical. So on the right-hand side, I have to FOIL, and I get 1 plus root 2x plus 5 plus another root 2x plus 5 plus 2x plus 5. Combine like terms, and so I'm going to have one of these radicals plus another one of these radicals. So I'm going to have 2 of these radicals. So I still have a radical in the problem. A lot of these problems are nicer in that once you square both sides, the radicals are gone. Well, this is a harder one, so not this type. So we have to combine these and then re-isolate. So I'm going to have x plus 14 equals 1 plus 5 is 6, plus the 2x, plus 2 of these radical 2x plus 5. So I'm going to re-isolate by subtracting 6 and subtracting 2x. Negative x plus 8 equals 2 root 2x plus 5. And now square both sides again. I could divide by 2. But I didn't want to create a fraction, so I consciously didn't do that. Now on this side, negative x plus 8 is a binomial, so I have to square that properly. So it's going to be x squared minus 16x plus 64. If you have to expand that and FOIL that the long way, please do that. Just get that right. 2 squared is 4, and then the radical and the square cancel, but that's a binomial, so I have to lock it up in parentheses so that the 4 can get distributed. So now that's 8x plus 20, and it's a quadratic. So I'm going to subtract the 8x over and subtract the 20 over. So I get x squared minus 24x plus 44 equals 0. 1 and 44, 2 and 22 will make 24. So x minus 2, x minus 22, and I get x equals 2 or positive 22. Which I need to check both of those. Again, it's not just a rejected solution because it makes the denominator 0 here. You'll see what happens when I plug in. So if I plug in a 2, 2 plus 14 is 16, root 16, minus root 2 times 2 is 4, 4 plus 5 is 9, root 9 equals 1. So that's a 4 minus a 3 equals 1. So 2 works. We're going to keep that. Now we're going to check 22. 22 plus 14 is 36. So root 36 minus 2 times 22 is 44. 44 plus 5 is 49. So this is 6 minus 7 equals 1, which is incorrect because 6 minus 7 equals negative 1. So 22 has to get rejected, and we only have one answer. On a system, which will a substitution type system, always will be a linear and something else. In this particular case, it's a circle. You solve your linear for usually y. If it's x, that's fine too, but x I wouldn't want to solve for here because I don't want to have to divide by anything. It's not going to be a nice number. So if I can avoid that, I am. I'm going to solve for y. I'm going to add the y over. So 2x equals 4 plus y, and then I'm going to subtract 4 over. So y equals 2x minus 4. So if y equals 2x minus 4, it's going in there. So I have x plus 3 squared plus 2x minus 4 squared equals 8. So my substitution of one equation into the other gives me an equation with all x's, which is now solvable. So I square the binomial by expanding and foiling. Square this binomial by expanding and foiling. You can hopefully do that out, or just trust me and see already that that's correct. And then it's a quadratic, so 5x squared minus 10x. And I have a 9 plus 16, which is 25, but I'm going to have to subtract 8 from both sides, so that's going to leave me with 17. And then it's not factorable, so to solve for x, we got to do the quadratic formula. Opposite of b is 10 plus or minus the square root of b squared, which is 100, minus 4ac, all over twice a is 10. So that's 10 plus or minus the square root of 100 minus 4 times 5 times 17 puts us at negative 240. So a negative discriminant. Talk about midterm review. Negative discriminant means two imaginary solutions. So I can finish this out. That breaks down into negative 16 times 15, which will be 4i. 10 plus or minus 4i root 15 over 10. And then the evens can reduce by 2. So 5 plus or minus 2i root 15 all over 5. So there's my two imaginary solutions. But when you're solving a system, you're looking for points where the line and the parabola cross. If you get imaginary solutions, the parabola and the line aren't crossing at all. So there are no solutions point-wise. The x answers are technically those. They're imaginary. Normally, if you get two x numbers, like x equals 7 and x equals 3, you'd have to plug back in an x equals 7 to figure out the y that goes with it, and an x equals 3 to figure out the y that goes with it to create points. But because this is a unique case and points don't actually exist, you're not going to re-plug in your x's to find corresponding y coordinates because that concept doesn't really exist. So a system in 3 variables is elimination 3 times. So you look at your x's, y's, and z's, decide what's the easiest to get all the same number. I'm going to say x's. So I'm going to double this one and double this one. So I get 2x plus 2y plus 2z equals 2. Not touching the second one. Doubling the third one. Now, first round of elimination with the first two equations, same sign, subtract. 2 minus 2 is gone. 2 minus 4 is negative 2y. 2 minus 6 is negative 4z. And 2 minus 2 is 0. Second round of elimination on the second two with the two x's. They're opposite signs, so I add. 4y plus 6y is 10y. 6 plus negative 10 is negative 4z. 2 plus 22, 24. And then my third round of elimination is deciding what's easier to eliminate, the y's or the z's. Well, it's definitely the z's because they already have the same number. So same sign on those, so we're subtracting. So negative 2 minus 10 is negative 12y. Anything minus itself is gone. 0 minus 24 is negative 24. So solve that, y equals 2. Back it up. If y is 2, 10 times 2 minus 4z equals 24. That's a 20, so I'm going to subtract 20 from both sides. Negative 4z equals 4. Divide by negative 4. Z equals negative 1. Back it up into one of the originals. Negative x plus 3 times your y of 2 minus 5 times your z of negative 1 equals 11. So this is 6 plus 5, which is 11. Subtract 11 from both sides. Negative x equals 0, x equals 0, and you have all three answers. Okay, last one. Solve this equation. Now, traditionally, we would try factoring first. Let's pretend it's not factorable by grouping. So I meant to give you one that wasn't. So pretend it's not factorable by grouping. They tell you this because the only other known method left to factor is long division. And if you're going to start with long division, you have to know some root to start with. So if 5 is a root of this function, which is the same as the equation, if 5 is a root, then x minus 5 is a factor. So we're going to divide that out as a way of quote-unquote factoring. So x times x squared gives you x cubed minus 5x squared. Line it all up, do subtraction. That whole thing gives you 0. So you bring down your 9x. You might as well bring down your negative 45 too, since that whole thing cancels. Typically we're left with something here and we go. Now we'll say x times what gives us 9x? It's a positive 9. And you get 9x minus 45, which we assume there's a remainder of 0 because they told us it was a root, which means it should be a perfect factor, which means it should give us 0. So we've just factored this into x minus 5 times x squared plus 9, and it equals 0. So the solving, now that it's factored, is to tee it up. So x equals 5, or x squared plus 9 equaling 0, square root both sides.
Good morning, Bulldogs. Please
3x.
stand for the pledge.